Dear students, in the last module, we talked about recursion, and this module is the continuation of the previous module where we defined an algorithm for binary search using recursion, and we did not discuss that how this function will be terminated. So in today's module, we will be discussing that how recursion can be controlled or how and when that recursive function can be terminated. So remember this function that we have initially the whole list and the target value which is being sent to the function, and then we are saying if list is empty. This was the statement which we did not execute in the previous module, and we will be doing it by today. Then we moved on that select the middle entry from the list and put it in the test entry, and then see if the test entry is equal to the target value, then it's okay, we have found the required name. However, if target value is less than, then select the sublist, that is the portion of list preceding the test entry, and that sublist should be passed to the search function again. So when we say that this is going to be passed to the function again, this means at this point this search function will be executed again by leaving whatever it was doing previously, now with the sublist which has been now passed by this function. So this means the actual list which was passed by a previous function is on hold, as the call of your friend was on hold in the previous module. And similarly, if the target value is greater than test entry, then the sublist is computed by getting the portion of the list following test entry, and that sublist is again sending to the search function. This means again the function is being executed. So let's execute this function for a normal value first, and then we will check or go for the when the list is empty. So let's have these 15 names: Abida, Ahmad, Asif, Aisha, Afzal, Bashir, and so on, and we want to search Zahid. So what would be the procedure? First of all, you know that we will find the midpoint of this list. So the midpoint is Khalid. So we will take Khalid and we will compare Khalid with the Zahid versus Khalid in the first step. So when we compare it, you can see that Z has bigger, larger, more ASCII code as compared to K. So this means that our required information lies in this list. So this is the sublist which will be passed again to the search function, and we will leave all of this and we will not be searching and going over here. So this means next time we have the sublist only starting from 9th position until 15th position, and then again we are trying to find the midpoint. So 1, 2, 3, 4, 5, 6, 7. 7 are the total elements, and the midpoint is 1, 2, 3, 4. Yahya. So now Zahid will be compared with Yahya. So this is the second step. And when we compared Yahya, we again found that Z in Zahid has more ASCII value than Y in Yahya. So this means our actual list is not from here, it lies in this. So in the third step, we are having only Yunus, Zahid, and Zubair. And again, we will find the midpoint, and that midpoint is Zahid. When this Zahid will be compared with the Zahid which was our query, that will be completely compared as the ASCII values of both Zahid and Zahid is equal. So we found our match. So let's test this first condition, that when the list is empty and how this function will terminate. So let's do it. So we now want to find, for the same example, we want to find Ajmal. So again, first step would be to select the midpoint, Khalid, and this will be compared with Ajmal. And when we compared Ajmal with Khalid, we found that this list is of our not of any use, and our required information lies in the first 7 entries. So this means Abida, Ahmad, Asif, Aisha, Afzal, Bashir and Fawad will be selected to be proceeding for the next comparison. So these are 7. Again, the midpoint will be selected, which is Aisha. So this Ajmal will be compared with Aisha. And again, we will see that A is matched with the A, that is fine. But Y is not matched with the J. So the ASCII value of Y is more as compared to the ASCII value of J. So this means that Ajmal lies in somewhere upside. So this means next time this list will be selected, and that is Abida, Ahmad and Asif. Next time we will select again the midpoint, which is Ahmad, and we will compare it with the Ajmal. And when we compare it with the Ajmal, we can see that H is actually lower than the Ajmal. So this means Ajmal can be found somewhere after Ahmad. So we will select Asif. So the next iteration, we will have only one entry as a sublist, that is Asif. And that is the midpoint as well. So that Asif will be compared with the Ajmal. So when we compare Asif with the Ajmal, so we can see that A is compared with the A, but J is not compared with the S, because S has the greater ASCII value. So this means Ajmal can be found somewhere upside. And you can see that in this list there is only one element and there is nothing upside. So this means this empty list will be selected, and this empty list will be passed on to the search function again. And when the search function will find this empty list, in the first statement it says if list is empty, yes, now the list is empty. Then report that the search failed. This means we did not find anything. So this is basically the recursion, or a perfect example of recursion, that how we have executed the binary search algorithm using number of steps and calling again and again the same function, and at the end we are left with the empty list that becomes the base condition or base case, or sometime it is called degenerative case for terminating or for completing the recursion process. So this first statement is basically the statement which is terminating this recursion process. So if we summarize today's module, we have in-depth learned about recursion, and we have seen that how the recursion can be controlled. So this means when we want to define a function using recursion, then the first statement of that function should be the base condition, should be some condition which should terminate that function at certain point, as we have seen that when the list was empty in our case, the function was terminated. But that condition should be written at the top of the recursive function normally, and then it goes either in the left side or in the right side, and so on.